But where did you so were you a professor, or did you just get your degree in it like way back, or
Yeah, so it
and
was 2001. I got my honors in biochemistry, and then we were moving into research. So I was planning to get my PhD, but I hopped around a bit from biochem, and then I went to organic chemistry, which was also fun at a university sort of a little bit further on in the country in South Africa. So yeah, it gave me a very broad discipline base. You know, the problem that we have, or we as scientists, is that you are expected to be very creative and contribute a lot of intellectual property, um, but it's a very political environment. Universities specifically, the more formal academia, and
Mhm.
I was maybe too idealistic, which is possibly why I also got into blockchain as a Puritan, and then discovered that blockchain as an ecosystem can also become quite political as well. I've always sort of
Mhm.
just wanted to do good science. That's what's driven me. And, just leave me in a lab tinkering with something and I'm the happiest man on earth. So I think it was sort of just after having spent a year or two in organic chemistry that I decided that entrepreneurship called to me. Very quickly realized the lab is not how the world works. And
Mhm.
I had to pay my dues, actually failing several times in small startups, not because of the product or the technology, but everything else. And through the school of hard knocks,
Mhm.
it was a very good opportunity to sort of hone your metal and discover what you're all about. And in those days, we were more focused in hardware and electronic signal processing, which is great because it gives you a very different view on development. We had a very
Mhm.
fun project. There was a professor at AMU University, Professor Laszlo Kish, who'd worked on a new hardware encryption layer called the Kish cipher, where he was using certain kinds of noise to give quantum level security, but for instead of paying $100,000 for a point to point encryption line, you could pay $50 and get the same security. And that really blew my mind because it turns out that physics and maths can do things that dramatically change cost centers, dramatically change risk profile. And after a while, I met my co-founder Rulo Barry, probably more towards 2013, and that's when the blockchain bug really bit us. I, from
Mhm.
academia, was a lot more skeptical, and the reason was very simple. It was being marketed as a sort of a libertarian technology, and it seemed to be more about the social space than the technology itself. Which is fantastic, which is good and necessary, but it's not something that I particularly can contribute to as a academic and former scientist. And after reading the Ethereum white paper, I really started getting a lot of insight into where the ecosystem was and the gaps, the very obvious gaps that needed to be filled with. And so that was a fantastic realization that there was opportunity. This was the Wild West. No one had
Mhm.
really formalized anything, and so you could really contribute significantly. I think as fields get more and more old in science, you notice that the authorship on papers goes from one author to two author to 50 authors because
Mhm.
making a continued contribution becomes harder and harder. And so that was just a wonderful experience. We had the extreme luxury of being very well funded and self funded for about the first 5 to 6 years. We had no stakeholders, we had no deliverables. The task was just get it right, build it slowly, and that was fantastic. So yeah, that's how it all got going.
Yeah, that's awesome. You mentioned, I just want to step back for a second, quantum level security. Like
Yeah.
what is that exactly? Like 'cause I have no idea what that is.
So the way that if you look at all sort of attempts to build a physical machine, starting probably from 1945, von Neumann and those guys, the old machines, you've always
Mhm.
used physical properties to sort of transfer and store bits. And so bits have to behave in sort of classical mechanical sense. They're either up or they're down. They're either on or they're off. and all your signal processing and design elements are focused around that. The real power of a quantum computer is that it can have an up and a down state simultaneously. It can superimpose states. So it can do
Hmm.
two calculations kind of off one bit. And that goes up exponentially the more core bits or quantum bits you add to a string. The problem with that is it changes the way it could potentially, with certain kinds of cryptography, really threaten security. And so the sort of natural solution is that if computation and transmission is happening using quantum states, then encryption should also use a kind of a quantum state as well. And so you could sort of quantum entangle photons and send them down some sort of fiber optic. And if you construct the physical hardware in just the right way, if anyone tries to make a measurement on the bit that's being transferred, they will affect the bit. And so they'll
Hmm.
not be able to, and that's going sort of down to Heisenberg's uncertainty principle and a number of other factors. But quantum encryption really is the promise that you can use quantum states to securely transfer information. It's normally extremely expensive. So what you do is using your quantum, you use them for key exchange. That's because keys are relatively short. And once you've established a secure key, you can go back to using more classical crypto schemes. But you could really use entangled photons as a way to communicate quantumly between two participants, but not three. That was really the promise. And it is achievable, but in reality, there's no such thing as, I mean, trying to observe quantum states as in Newtonian scales, there's a lot of practical considerations. And I think in 2010, a team out of Toronto actually broke the first quantum key exchange hardware devices,
Hmm.
fully broke them. And that was a shock because the NSA and several other agencies had built these kind of quantum key exchange networks running over several miles underground using photon based technology. And to have your $100,000 point to point modem break because of a polynomial was kind of sad. So there was a competitor technology at the time that you could use basically certain kinds of thermal noise, Johnson like noise. And the idea would be that it's quite easy to understand it at high level. Um, if you put two high value resistors, you pick a high resistor, I pick a high resistor, the sum is two because we pick high as one and low as zero. If we both
Hmm.
pick a low resistor, the system sums that to zero. In both those cases, the network ignores the signal. But if you pick a one and I pick a zero, or I pick a one and you pick a zero, the summed resistance on the wire is one, and the network records that value. So what Alice and Bob see during transmission is 1, 1, 1, 1, 1, 1. But because I picked a one and the line was one, I know your state is a zero. And so we're communicating and we're building up these kind of random, highly entropic keys using nothing but high resistors and low resistors. It was a very elegant solution, and it gave you that kind of future-proof, robust security. So that was a really fun project, which
Hmm.
unfortunately was also quite political.
It's really difficult though to build a computer up from the ground up on the quantum level. Like it's definitely going to take a long time before that's ever something that's commercial. And if it exists at all today, like in any form, there's no way that they're telling us about it because that would probably break everything. Is my guess in terms of computing power.
Brandon, absolutely. The target would be 100 core bits. If you could generate truly 100 quantum bits, you have a register that's 2 to the 100. You could then sort of simultaneously really brute force and break a lot of especially asymmetric encryption, which is weaker to quantum
Hmm.
computation. It would be extremely advantageous to whoever developed it, but it does assume, and I mean this is now me, this is the academic Andrew speaking, it does assume that our understanding of quantum mechanics is correct. And I think part of the difficulties, I mean, China has, I think, true quantum bit extensions. I know that they've hit 7 quantum bits and maybe 11. You can sort of cluster them to get to maybe 40, but we're a long way off from 100, a long, long way off.
Hmm.
And part of that challenge is the difficulty in taking quantum measurements. But possibly, and more excitingly, part of it is that we don't have a good description of quantum mechanics. And so there you've got other theories like matter waves and de Broglie pilot waves, which if you mention them to classically trained quantum mechanics scientists, they sort of break out in a cold sweat and go, not matter waves again. But there's definitely, I think, still some physics to understand. So yeah, it's I wouldn't say we are going to realistically see these things in the next 10 to 20 years easily.
How do they do that though? Like you can't, 'cause I know you can't know a particle's position and like velocity or whatever like at the same time.
Yep.
So is there like a special process to like look at these on the quantum level or to like make it work? Because it's hard to wrap your head around, even when you do have a background in neuroscience or biochem or ochem or quantum mechanics kind of throws everything out the door in terms of what we know. But is there like a process for that, or is it like really like technical or and really like expensive? I bet.
Yeah. Well, so when you're dealing with a sort of what I would call a sort of a static quantum bit that's floating in a jar, you don't really have to worry. Well, yeah, I mean, you've got to worry about Heisenberg's uncertainty principle to some extent. But luckily, we have machines. The early attempts were really interesting because they used NMR machines. So, I mean, what NMR does, it puts an organic molecule or any molecule really into a magnetic field. And then when you apply and it'll align either in the parallel or anti-parallel state to that magnetic field. But if you can give it just the right amount of radio frequency RF, it will superimpose to being both up and down at the same time. And so you
Oh,
could kind of
okay.
using RF, which is great because obviously computers you can program RF. You can put these things into a superimposed state by applying the right radio frequency as a way to kind of program the molecule into different states, and then depending on its outcome, you can read back the expected results. But the problem is that relies on the fact that there's a unique chemical bond. And that's why they were making these weird organic molecules that had 7 or 8 unique bonds, like a carbon oxygen, carbon sulfur, carbon chlorine. And then you could kind of write to the CCl frequency using the right RF frequency. So that was kind of how they were doing it back in the early days. I know they've moved on since there, but that's really how you can sort of program and induce superimposition of states on a particular, resonant bond.
Mhm.
Yeah, it was.
Here's a good question. Here's a good question. Do you think that quantum computing could break blockchain or
Mm.
potentially break a weaker form of encryption with some of them, like Bitcoin, for example?
Now, Brandon, now that is a very, very interesting question. You know, it's an interesting observation that symmetric ciphers, so that's the Advanced Encryption Standard or AES, is inherently quite resistant against a sort of a post-quantum universe where people have um, cheap and quick access to quantum computers. It's really the asymmetric key pairs that are most vulnerable.
Hmm.
And the reason I mention this is we're currently using elliptical curve cryptography as the basis to sign for Bitcoin payments. And they, of course, are asymmetric. They're private public key based cryptography. And they really will be weakened substantially in the presence of a quantum computer. What's even kind of more alarming is if you have built your blockchain network to be proof of stake. Proof of stake is that the mining process, not the mining process, but their equivalent consensus mechanism depends on how many coins I've purchased or what my stake in the network is. And of course, that's also dependent on public private key pairs. Whereas when you're sort of computing sort of hashes, you're more moving to the symmetric family of crypto ciphers. Proof of work, I believe, would be more resistant to post quantum attacks. But I mean, that's also neither here nor there. But yes, the signature schemes really need to be looked at. And so there will have to be sort of zero-day protocols built into future blockchain technologies that allow us to upgrade from signature scheme A to signature scheme B to prevent such attacks. But quantum mining, is that a thing? Um, I haven't yet got a very satisfactory answer for that. My gut intuition tells me um, quantum mining shouldn't be a thing. Hashes are essentially derived in some way from symmetric cipher blocks. And so I'm sort of, having not really had enough time to delve into it to the level that I should, they should be more resistant to post quantum. But the big question for me, which I don't see a lot of forums discussing, is what does a post quantum machine mean for mining? But yes,
What does it mean for mining?
well, I mean, now we have to discuss incumbent technologies versus sort of maybe our
Mhm.
technology. And there was an old idea, really sort of given a lot of credence to by Cloud Shannon. In the old days, when people were trying to sort of communicate over a cable, the quest was to build a better cable. You would move from maybe silver wires to, let's say, copper wires, and you might have a better conductivity and bits would be dropped less. And then obviously fiber optic gives you a better transmission distance and quality. So engineers were constantly looking for better and better ways to build signal carrying wires, which is a whole art in and of itself. And Cloud Shannon came along and he said, if you have the right mathematical encoder, it doesn't really matter how bad the physical wire is. You can build in noise tolerance into the wire. And so he had a number of coding schemes. I think one of the popular old cyclic redundancy checking coding schemes was Hamming codes. And the idea of a Hamming code is that you could recover a dropped bit by looking at the sort of the redundancy and error checking part of the code, the encoding scheme. So that was a way to say you don't need a perfect wire. You need adaptive mathematical encoding to make up for the lack of a perfect wire. And we've been trying
Mhm.
to chase kind of the perfect hash function for a long time. So when you go back to probably 2012, 2013, man, those are good days. That's where the conversation was real. The fintech boys hadn't kind of corrupted the initial vision of blockchain. I see it very much as kind of like the Rebel Alliance versus the Republic. You know, this
Uh-huh.
to use an analogy, crypto is at a crossroads, to be honest. And I'm not trying to say that as a doomsday prophet. We really are stepping into a dangerous space where the people who are trying to drive mainstream adoption don't really understand what the tech is trying to achieve. If you look at the conversations we were having in 2012 and 2011, and maybe even as early as 2009, the questions were, this is a platform that enables collaboration. And I'm not talking about holding hands and dancing off into the sunset, but that any free market should be a collaborative space. And that doesn't mean it's not competitive, and that doesn't mean you don't have winners and losers. It's got nothing to do with that. But the competition should be free and fair. That's the dream of a free market. If you find a free market, will you let me know? Because you have a lot of things like trade related investment measures. You have a lot of people with special interest groups protecting their market space. And the idea about this new potential form of electronic cash was to take it and build a new form of an economy. One of the beautiful things in the Ethereum white paper referencing Satoshi's plan was that it was a social fix. The idea was everyone's got a computer, everyone can participate, everyone can get some coin, and everyone can go out and do something intelligent with it. And I think the one uh, Satoshi Nakamoto really was a genius. I mean, we've spent a lot of time going through his original code base. We've had to recode a lot of stuff into Rust, which is the language we're deploying off of for reasons we can go into.
Mhm.
It seems to be very much like the man who wrote the code was definitely one individual. I can't say whether the whole team was just one man, but the way the code is written definitely looks like a single coder. And for him to have such knowledge of network protocols are two things that if you learn at a university that probably won't equip you for the real world. It's cryptography and network development. There you kind of have to learn it. You can learn the theory, but you very quickly have to acquire skills from the real world. It's a very very different discipline, when you have to deploy off of it. And here Satoshi clearly really understood network mechanics deeply, and
Mhm.
I think the thing he missed was the rise of the ASIC and hardware accelerated hash function, which really broke this idea that anyone could participate. And it turned it from, and here's where people that criticize proof of work criticize the implementation of proof of work. They fail to understand the concept of proof of work. Yes, proof of work now is sort of more capital intensive. People have more capital, can do more mining. But the whole point of selecting a hash function was that it wasn't about capital, it was about participation. What a powerful idea, man. I mean, that's where it was at.
Mhm.
Now we're talking about banana coin, and again, I don't want to knock any coin. They all are creating fantastic financial instruments, and that's a great
Sure.
way to give it relevance to the world that typically think about, how do I turn $1 into two as their primary focus. But we've lost the core focus, and that these things weren't meant to be price backed. We were supposed to be building something that was value backed. So going back to this initial sort of discussion, everyone understood we had to find the golden hash function. That was all the discussion from, I don't know, 2011 to maybe 2014. Litecoin, their whole premise was that scrypt or script, there's two pronunciations, it depends which one you follow. But their whole hash function that Litecoin was trying to build was going to be memory hard. And this was going to move us back to kind of the golden vision of everyone can participate and you can't really hardware accelerate it. It's more free and fair. But of course, it wasn't long before it was found out. And you notice that when their hash function was broken, when scrypt or script was hardware accelerated, they suffered major 24-hour losses in their market cap. I mean, it was more than 25%. I mean, I can't recall specifically, but it was a significant knock to their market cap. And now we fast forward many years later to IOTA. When their hash function broke, that price just kept on
Mhm.
ticking. There wasn't even a register. And that just tells
Right.
me that people have forgotten what everyone was talking about back in the day. So our approach, and now you have problems. So hardware acceleration is a general problem. And when hardware becomes quantum hardware, going back to the original question, certainly with respect to the signature scheme, this will be catastrophic. And we have to go back to what we learned from Cloud Shannon and realize that it's not about building a perfect wire. It's about choosing the right encoding that even when the wire breaks, the mathematical function still operates. So one of the things we're very proud of is creating a new class of function that uses hashing as a component, but it's adaptive. It has its own encoding. And so it doesn't really matter what hardware you're running, you're going to mine at more or less the same rate on our network. This
Mhm.
has deep and profound economic consequence because most of the incumbents today are hardware accelerated. And so we've chosen, for various reasons, not to create a perfectly flat competitive landscape, but to bring the order of magnitude between somebody running an ASIC and somebody running a CPU, instead of it being 10 to the 6 competitive gap, something to the order of 10 to the 2. So that's something we re- we would really be excited about discussing with the community. That's who we want to talk to, the 2012 crowd,
Mhm.
the guys with that hat on. That's who we're
Right.
excited to engage with.
Man, I would have loved to take one of your classes in college. I feel like you'd give the best lectures. It'd be awesome. Talk about crypto and quantum computing and theory and economics all in one. Oh my God, that'd be great. Um, no, it's so weird about Bitcoin though, 'cause you touched on that earlier, is, the timing of it. Like, obviously, whoever Satoshi is, or if it's a group of people or an entity or whatever, um, they had a lot of knowledge about networks and hash functions, but also on economics to build something that's sustainable, that's actually completely disrupted the global financial system, and that was introduced at a time where the trust in the big banks and the banking system and our fiat systems were being tested and at all-time lows. It's really, I don't know, the timing is really interesting to me, and not a lot of people really talk about that. Isn't that weird?
Brendan, you and I, we're like-minded people, I can tell straight away. Now, what's interesting is that there's really maybe 4 or 5 academic papers that should be kind of canon and should be read repeatedly. The first one, which doesn't get as much limelight as it used to, is Moni Naor and Cynthia DeVork's pricing via processing. That is a powerful idea.
Hmm.
Because the idea was that they'd come back, the story goes, and in their paper from vacation as professors in academia to find the inbox full of spam, and this kind of annoyed them, and they wanted to know how could you get rid of spam. It was a simple idea. If you priced an email even at 1 cent, it would just kind of price spammers out of the email market. Now that's very interesting because they're using economic thinking right there. They're treating a market not as where you go to buy stocks and bonds, but where you go to uh, purchase your email. And that's a kind of an interesting idea. So they're trying to look at it as management of a resource, which is very cool. Okay, and they realized that
Hmm.
using a hash function, finding a light kind of proof of work that would validate an email would not put a dollar price on sending an email, but spend an economic price to generate an email. So if you're only making one email a day, you can afford to pay that cost computationally. But no one could afford that cost to spam. And so from the beginning, anything derived, ultimately Adam Back took that insight and developed the Hashcash protocol, but it was economically constructed from the beginning.
Hmm.
But there's a word in there that there's two words. If you really want to get down to the philosophy and like the low level inner workings, there were two words that were kind of just slotted into discussions um, because the function was called a pricing function. And I mean, when Moni Noor and Cynthia DeVork were using it, I'm not sure that they were sort of fundamental price theorists. And I don't think they'd spent incredibly long amounts of time pondering on what pricing is all about. But had they done so, they themselves might have come up with something like Bitcoin. Pricing makes things rational actor proof. And so you hear a lot of people saying, well, the Bitcoin protocol isn't irrational actor proof. I know, and that's why it's a great thing. It's
Hmm.
the thing about rational actors and the thing about pricing is that prices are always efficient because if anyone breaks the efficiency, so if you're doing an arbitrage trade, you found an inefficient pricing mechanism. Pricing always becomes naturally efficient. It's entropy aggregating. It will self-correct because if the price of wood goes up, what does that tell you? It tells you there's not enough wood. So it provides both the incentive, people jump out of bed and start making more, and it sets kind of a quantitative amount of what the imbalance is. And so if you're now using the Hashcash protocol, which is based on pricing via processing, the processing power will always price itself efficiently. And that's how we see the Bitcoin market of miners synchronizing their hash rates through pricing how much it's worth for them to send that email to claim that block reward. And so, I mean, these things were built in from the bottom. And we have to go back to that pricing idea and build it out. And the second one, just very briefly, is that the thought that Vitalik had, if you read one of the Ethereum white paper is a living document. It gets updated. And so I don't know if, the versions that I've noted mentally are the
Hmm.
active versions sort of circulating on their Git repo at the moment. Um, but the one that fascinated me the most referred to the attempt to build a state transition system. And the idea was that you had a tuple sort of A comma B comma 5, which was Alice pays Bob 5 ether. And that would represent a state change from S to S prime. It was a kind of a state transition system. That's fascinating. And the reason is in thermodynamics, there are two functions, only two, that describe all systems. There are path functions, and we're going to get back to that in a second, and there are state
Hmm.
functions. Now, calling something a state transition system really means you're defining a version of a computer. But this for us at Zenotta was a penny drop moment. We're not building a state system. We're building a path system. So I'm going to describe both very quickly, and you tell me which sounds like a blockchain. Okay. A state system means that I can go from state A to B and from B to A reversibly, efficiently, and optimally. Why you'd want this is if you had a limited access to a certain amount of memory and you wanted to efficiently do computation, you want the memory to be cheap. You want to be able to erase over it and dump the next value onto the stack, chuck it out. The order of operation should not matter. And most modern microchips they don't preserve the order of operation. So if you tell them add 3, then 5, then 7, they might say, well, 3 plus 7 makes 10. So I'm changing the order of operation because it's just a state. You just need the final state to be correct. The path has nothing to do with it. It's perfectly reversible. Now, what about
Hmm.
path functions? Okay, that's a state system. And to me, that doesn't sound like a blockchain.
It's not. It's because a blockchain it's linear and it moves forward in one direction. You can't reverse.
Exactly. Now, path functions, because of the aggregation of entropy, if I drop a plate on the ground and the plate smashes, I can't just dump heat into those fragments and expect the plate to reform. It goes one way. And for us, we were like, man, everyone's trying to build a state transition system out of a blockchain, but they're supposed to be building a path transition system. And that got us really excited. And that's kind of been our sort of, we've kind of cheated because you can map things, you can translate them into, if this was just a physical engine, what parameters of the system are we trying to maximize? Are we trying to minimize enthalpy or maximize entropy? And as soon as you know what you're trying to maximize, the system kind of builds itself. And it's as correct on Mars as it is on Earth. It's universally correct because physics is more fundamental than people in terms of how machines operate. So this got us really excited. And we've really spent like a lot of time building this into our blockchain. But yeah, just going back to it, 2012 was a great time to be a blockchain enthusiast. We are so excited to see how people have integrated it. But we'd like to go back to that discussion about collaboration,
Hmm.
game theoretic collaboration, which means everyone gets a voice. And collaboration only works if mining is free and fair. Everyone needs to be able to participate. That's kind of um, almost canon. That's what you want to bring back. You get there by fixing the hash function problem. There's several other things you have to do. Pricing is very important to bring into it. And Brandon, you must just stop me if I'm rambling.
No, no, go ahead. This is great.
But using that example of wood and pricing, there's a real problem with the way that the Bitcoin blockchain ledger is written, and in fact all ledgers. They look like, if you were an alien studying the transactions in isolation, you would come to believe that this is a gift giving economy, because it records that Alice gave Bob 3 Bitcoin, but for what? It's not recorded on the ledger. I mean, there might be a
Hmm.
hash that references some external document or whatever it is encoded in that transfer, but it isn't a dual entry, it's a single entry. In our ledger, the first thing that we had to develop was a data protocol, and we can discuss that a little bit later, but it records the transfer of rights of ownership for any data, whether a JPEG or be it a PDF, from Bob to Alice. And for that PDF or JPEG or in-game item or medical data, Alice pays Bob 3 Zeno. So our ledger prices the assets under management. And if you're not pricing things, you don't have a market. And what blew my mind, now I'm of the opinion that if you are singularly one thing in your mind, you will breed in weakness. Blockchain is about oracle thinking, it's about decision making, and it needs to marry computation, which has nothing. Computation and decision making are two arms of process. In the old
Hmm.
days, you used to do everything on a typewriter. Now we can do our calculations on a machine, but we're still doing decision making with bits of paper. When you need to decide on a vote, you make a cross on a piece of paper. When you make a decision economically to pay for a banana, you hand over a paper piece of money. When you go and try and decide to join an association, you fill out a membership form. And so to this day, anything that's decision based, there's a piece of paper waiting for you. And that's because oracles were never built that could be autonomous. We had autonomous computers, but not autonomous oracles. And that's the gold standard, because oracles, unlike computers, can never be general purpose. So you can have an oracle that solves the halting problem, or you can have an oracle that solves the knapsack problem, but you can't just have an oracle for all decisions. That's something that can't be
Hmm.
constructed, and it's to do with the nature of you know oracles rely on knowledge. They use a list of memberships to say, are you part of this membership set or not? So an oracle, a good example is you're going down to the golf club. and there's a guy at security, and he's got your name on a list. That list and name and his action to make a decision, he fulfills the function of an oracle as Alan Turing understood it in 1938. And in that regard, you need that man with his sheet of paper to be replaced by a machine. And Brandon, this is the most important thing. If you have
Hmm.
humans typing that information onto the oracle lists, certain enterprises do that, and they use reputation as a fallback to defend the entries. That's not an autonomous oracle. And what I wanted to drive all of this to was, what are we trying to do? You mentioned trust, and that's really what started this entire conversation from my side. What's amazing, Satoshi Nakamoto never really went on about trust. He was going on about efficient decision making. The reason two engineers use a calculator when building a skyscraper is not that they don't trust one another, it's that they need to efficiently compute.
Hmm.
But the secondary effect of efficient computation is trust.
Yeah,
When,
a trustless system.
exactly. You don't have to trust because the computer checked his work. That's exactly it. So when you have an efficient and transparent system, you won't need trust. That's kind of the beautiful two for one sale. But you can design systems to address the trust issue that aren't efficient, where you have humans typing in things that's reputationally based. We're really on the quest to build autonomous data oracles. That really solves the efficiency problem. And when your machine needs to be convinced, so I hold up a digital asset and I say, this in-game
Hmm.
item over here is worth $1,000. Your logical question, Brandon, would be, prove it to me. I've made that sort of claim because I have knowledge that you don't have, but you're not going to just take it at blind faith. You need some sort of evidence. And more importantly, your machine needs to have that level of evidence.
Hmm.
Proof of work is the observable quantity that gives me confidence at machine level. If something has changed hands for 6 blocks, I have a 99.99% confidence that this has not been double spent, that I am the intended recipient and now witnessed by the network as the legal owner. You can never have anything based on consensus be 100%. Not everyone on earth agrees that I'm Andrew Kessler. And so we're not trying to get a Boolean true or false. That's what computers do for numbers. We're trying to get that confidence extremely high, higher than it would be in any alternative system. And with that sort of thinking in mind, proof of work is something a machine can give another machine to convince it that the entry has not been contested, that the community is in agreement about a certain value, and this machine has something empirical that it can observe to convince it that a certain decision is correct.
Hmm. So, with all of that said, how does that help? Is it
Zenotta.
Zenotta? How does that separate Zenotta from other blockchains? Is it mostly the Oracle process? Is it the smart data? Like, what is the main thing that really separates it and makes it stand out?
Firstly, we've been able to extend proof of work. I mean, we're going to build this out like we were building mathematics.
Hmm.
What's interesting about mathematics is that geometry turns out to be more fundamental than algebra. So you can derive algebra if all you had was geometry, but you wouldn't necessarily derive all of geometry if all you had was algebra. This is a sort of a fairly recent realization in mathematics. So some things are more fundamental to solving the world's problems. What we want to do is have every time enterprise use a piece of paper for a process to get rid of that and to be able to represent that through a machine-driven process. Then we will have efficiency everywhere. It turns out that people really only keep bits of paper around things that have value to them. So if there's a piece of fluff on the floor, you're not going to write down a record that there's a piece of fluff. And value is a tricky word because it describes relative value, which is sort of an economic way to think about the world. I value a cup of coffee not as much as you value a cup of coffee, which is why you pay
Hmm.
$5 for it and I don't. That sort of thing. or $10 or whatever currently is a ridiculous amount to pay for a cup of coffee. That's subjective, but that's really the
Hmm.
point. Whereas law and notions of law aren't about relative value, they're about absolute value. There might be a mitigating circumstance in a particular crime, but if you are unaware of the fact that murder is wrong, it doesn't exempt you from the law. And so, from a judgment perspective of have you broken a crime, there's kind of an absolutism to the notion of value. And then social value is a different kind of value altogether. So we want to be able to represent all of those bits of value, which normally occupy a sheet of paper, and allow machines to make decisions about these processes. So we want to find solving the data problem with a data oracle allows you to address all of these issues. When people mention data, they're typically talking about a field in a database. So when you hear that they've put data on the blockchain, they mean like a property register where there's a serial number associated with a title deed or a serial number associated with an identity. And these serial numbers have now been put under blockchain governance. And the reason for that is it's impossible and it's inefficient to try and load very large files directly onto a blockchain. And it's a bad idea, not just because of technical limitations, it doesn't preserve privacy. Would you really want your title deed to be a matter of public record for all the world to read that you live at this address? It would be a nightmare. And so for this reason, you have this weird state of data. The data will have to live off a blockchain, but be governable from a blockchain. Tokens don't have that problem. I never really have my token in my wallet. I mean, I have the private key that allows me to signal to the network that I am authorized to unspend it. But the tokens, if you want to think about them as living anywhere, they live on the blockchain, if they live anywhere. And so a blockchain is a contained universe, but files live in the real world. Now, if you look at NFTs currently, and the sort of the disaster stories coming out of some of the NFT trades, it's because they don't have a way to synchronize the data universe beyond the blockchain with what's happening on the blockchain. So if I could say to you, what are the challenges that you have to overcome in order to put data meaningfully under blockchain governance, then you'll understand the unique selling points and the unique value proposition of Zenotta. So firstly, we want an I'll explain why the term. We want a hashless signing scheme to put data under blockchain governance. And the reason is hashes show you that a record hasn't been altered, but they don't really convey to you. The problem isn't producing a signature for a document. The problem is the document itself. If I had two bearer bonds or I had two birth certificates, and I gave one copy to you and I kept one copy, each of those birth certificates have the same binary. They're hashed to the same value. But they should be able to have different digital pathways in the universe. I should be able to have a red birth certificate and a green birth certificate and send the one to my government for record keeping and the other I keep as something private and personal for my effect only. In other
Hmm.
words, we don't want and this is actually worth unpacking a little bit. Networks have given people utility through access. We want to open up access. We want to give people data. But if your ownership is based on a hash, or your ownership is based on, which is to say, I keep something secret, and after some point in time, I can show you that the hash matches. The problem of having to keep it secret means that you can't look at something and evaluate whether this is the artwork I want to buy. So the whole idea of
Hmm.
secrecy, of access control, flies in the face of network utility. You can't keep some data secret and have it have utility. So hash-based or access-based ownership models don't work over a network. You need them to be identity-based. You need to be able to say, and the identity isn't of the user, the identity is of the file. You want to be able to give a PDF red binary as your birth certificate, which is your right to claim, and give a green copy to me for admin or whatever it might be. That's the first major challenge, is how do you put data meaningfully under blockchain governance while preserving privacy? And incidentally, the idea of a red file and a green file and having the files off chain is great. Even if a quantum computer broke the security of our ledger, we don't keep the files on the ledger. We keep the color of the file on the ledger. So knowing that there's a red object out there doesn't allow anyone to do anything malicious against that
Hmm.
technology. So our first unique selling point is that we found a way to take a file and sign the file and make it unique at an identity level. Anyone can look at the red file, but nobody can write with a red pen other than yourself, and so they can't run away with your data. So we're moving away from having access being a thing. Now that's crazy because server level, old systems are developed using server client architecture. And the big data corporations keep everything on their server behind a firewall because it's access-based thinking. The way you get onto your Netflix account is by getting access through your password. And if you lose your password, you've essentially lost ownership of your Netflix account. In our universe, access isn't the thing that we claim ownership around, it's identity. So you stole my Netflix access. You stole the green file and you ran away with it. If I find you, I can point to the green file on your machine to any judge and say, look, that's my property over there, and have it returned. And that isn't a metaphor. We are literally building out a court and a legal framework here in Switzerland that people can come to us and claim file theft. And we can use alternate dispute resolution and arbitration as a way to give them awards. And so you no longer have to worry about the access issue when dealing with your data because it's provably yours. The second thing is the dual double entry, is that we price goods and services. Meaning I can look at the last 10 owners of a particular file and what they were prepared to pay for it and get a predictions market pricing. I can not be told the price of this asset is $1,000. I can procedurally compute the price of the asset. My machine, while auditing the blockchain, will tell me that the going rate of this piece of data is $5. Now, the owner might be asking for $4, and I can make a very informed decision to say, that's a good purchase because I'm getting it below market value. And that's really enabling the digital economy. The second thing about our dual double entry that's particularly unique is we manage the simultaneous transfer of the assets with the payments because they're both going off a fully distributed blockchain. So what
Hmm.
that means is either you get your NFT in our universe and I get the payments, or none of us get it. Our transactions are atomic, so it will roll back to the previous state, or it will conclude the transaction. So that's really maturing the thinking around trade. Going back to my initial statement, a blockchain is a gift. A Bitcoin blockchain is a gift-giving economy. It's one-sided. The dual double entry fixes that problem. And that will allow a coffee merchant, for example, in the future, before he receives payment for his coffee, he can generate a digital receipt on our system and say, I only want to be paid from coins that were greenly mined. If this coin
Hmm.
had an energy footprint of more than 10 carbon credits, I don't want to accept it for my coffee. Another thing a merchant can do is he can say, I don't want any coins that have been sanctioned by the US. I only want to accept unsanctioned coins. Or he can say, I only want to accept a coin if the provable security of the network is above a certain percent. And what is that? That's machine encoded service levels. So
So
yeah.
I have a quick question. So, this simultaneous like trade or swap or purchase, is that different than like traditional smart contracts with blockchains where they have like almost this like on chain escrow process?
Oh, it's very different. So what you might do is you can put a coin into a smart contract and put it under escrow, but you're
Hmm.
not putting a 1 gigabyte movie under escrow. It's legally under escrow, but that file is still sitting on my machine. You still need to get it from me. So when the time comes that I physically have to move that 1 gigabyte of data to your machine, how do we do that?
Hmm.
You've got $1 million. I've got a 1 gigabyte movie. Who's going to go first?
Right.
So it's contracted. You have a claim, but that's if you read some of what's happened in the NFT space, that's no comfort. Well, that's cold comfort once the payment went through and you should have sent me the file via FTP, but you didn't. So we have a whole way of synchronizing the transfer of the rights. So you can think of it as what you would have to do to buy a Ferrari. You'd need to get the slip to the Ferrari, a certificate proving that you are the owner, but you still need to get the Ferrari itself, and they need to get a whole lot of cash. We are able to do all of these transfers simultaneously tied to the transaction, so that by the time the seller gets the cash, the buyer gets the goods, which is extremely novel. There is absolutely no other blockchain that does this at blockchain level. And so the thing that gives Byzantine fault tolerance to the seller also gives Byzantine fault tolerance to the buyer. You'll read on our website that we talk a lot about trade. And the idea of using the word trade is to show that a dual double entry on a ledger is both for the merchant and for the client. Whereas
Hmm.
currently, anything that you do is sort of merchant facing, even if it's an escrow contract where some tokens are held under management.
Okay, that makes sense. In terms of data, what type of data are we talking about? Are we talking like files, documents, contracts, things like that? Or are we also talking about like almost like metadata, like the fact that I like chocolate ice cream, or that you like long strolls on the beach, like little tiny details that may be valuable to a large corporation or something like that? Or like what kind of data are we talking about exactly?
The beautiful thing about our data protocol is it's agnostic of the type of data. If it's being
Hmm.
represented as binary, we can put it under blockchain governance. And so here, the example with Facebook would be that at the end of the day, they're profit driven. They've got stakeholders that they need to give a dividend check to at regular intervals. And so, with that
Hmm.
in mind, what and I'm using Facebook with Liberty. I'm not suggesting that in any way they've discussed a project with us, and I'm not saying that it would be in their best interest. I'm just using them as a thought experiment. Facebook could now come to you and say that you will become your own data controller because you will be placing all the content that you generate on your client side will go through our data protocol and be provably your own property and encrypted. Only people that you specifically appoint to have access through your browser to your smart data will be able to decrypt it and prove that you're the owner of the blockchain. They can oracleize it on their side. So if someone's trying to impersonate you, that's no longer a problem because they would be writing with a different binary color pen. They don't have your binary pen when producing your content. What Facebook would then say to you is, we can prove to you, because your data is moving over encrypted channels peer to peer, it just happens to sit on our server for a period of time, but we don't have your keys, we can't gain access to it. And you can see any of the movements that happen because it's all on the blockchain. We are now going to charge you a subscription fee of $10 a month. Alternatively, you can allow us to take ownership of this file, but as soon as we have ownership of it, it goes onto the UTXO table. You can now subscribe to the UTXO table, and as soon as Facebook on-spends that file, you can be alerted as to who they on-spent it to. Because now spending isn't
Hmm.
just the act of transferring a token, spending is the act of transferring data. Now, Facebook wants to do this. A $10 subscription fee a month is more than they get from selling your metadata, but they're giving you choice. It's now about collaboration. We're now back to 2012 and back to what is a blockchain supposed to be doing. And it's doing this efficiently. Trust isn't the issue, efficiency and transparency is the issue. I have a right to say, I like a free service. I don't care if you market me to Coca Cola. I do have a problem if you start giving it to medical research groups. And at that point, I want to no longer subscribe to free data. I'll go to the $10 subscription model. Now, Facebook here have achieved a great advantage because their entire network overnight has become GDPR and CCPA compliant. Why? Because every human is their own data controller. They've parallelized that entire process. So compliance now isn't a burden, it scales. It gives choice to the consumer. In the old days, we used to call our data protocol the Magna Carta protocol because we really wanted people to think about the problems um, that faced England in sort of 1215. The landed
Hmm.
gentry were being kind of abused by the king. Owning property didn't really have any meaningful weight. The king could just seize your lands with impunity. And that's kind of when you're talking about metadata, the data giants, we don't have to name them, we all know who they are. They've kind of seized our metadata with impunity. And we're not naive enough to say that they will let go of that model because they like us. We can offer them a deal. We can offer them a fair tax. We can say that some people have a price to their privacy. If you're a high ranking official and you know that you can keep all of your Facebook chats under your control and keep control of all of your metadata for $10 a month, you certainly will do that. But it's all about choice. And that's really where the application for metadata would be within our system. And the
Hmm.
application for data would be around documents now being sort of witnessed by a blockchain, which means when you take a photograph of your bearer bond, that photograph is provably scarce. There's only one copy of it, and you can prove it to the bank, which means you can walk around with that bearer bond on your phone. You don't need the physical paper.
That's I feel like that's going to be like a really really important thing in blockchain is what happens with these big corporations and the way they handle our private data, like the metadata and stuff like that, because I think it'll be even more beneficial for them, to have a contribution system to, whoever the user is that wants to, maybe make 10 cents for selling that information or something like that, or being able to have a three-way with an advertiser and some website host or something like that. I think basic attention tokens doing that as well. There's just a lot of different ways to apply blockchain to a lot of common problems, especially around big tech. So it's really cool to dive into that stuff. I know we could probably talk about it forever.
Absolutely.
um, but tell me what's on the horizon for 2021 with Zenotta, Zenotta,
Zenotta, yes.
Zenotta. Okay, I don't want to get that wrong.
No, both we've had it pronounced both ways, and it comes from the idea that uh, you get a megabyte worth of data, and then after that it's a gigabyte, after that it's a terabyte. When you get to roughly 2 to the 90 bits, you now have a Zenotta byte worth of data. And so
Hmm.
Zenotta byte is spelt with an X, but for a variety of reasons, we spell it with a Z. And so that's just where Zenotta as a word comes from. It's the amount of data we predict um, will be collected in the next sort of 50 to 100 years globally. And so the data problem is a large problem, and hence the name Zenotta. Um, we have now built a data protocol that can handle any form of binary representation and put it in a hashless way under blockchain governance in a meaningful way that gives you
Hmm.
right to ownership. And we have a scalable proof of work network that currently can handle hundreds, if not thousands, of transactions a second, but it can scale somewhat arbitrarily to meet data needs. If you're looking at how many times people buy and sell gold globally in a day, it's a handful of times. There's maybe 1,000 or 10,000 gold trades in any particular country. And so if Bitcoin is more closely related to BitGold than it is to a dollar, it certainly doesn't need to solve the scalability problem. It's sufficient as a store of value. But when the Zeno acts as a medium of exchange, and what you're exchanging it for is valuable data, be it an in-game item, an NFT, medical data, 6 transactions a second just isn't fast enough. You don't even need to hit Visa speeds, you have to hit kind of Google speed. And with that in mind, we really, really had to go away and solve the network scalability problem while preserving proof of work, which, if you've been in the space for long enough, you'll realize that's completely not a trivial problem to do at all. So having solved these two problems fundamentally, we now need to look at how we engage with the universe. So our universe is beautiful, and we invite everyone to join us, but we need to link to the sort of bad, ugly world of the internet. So we're now looking at a variety of projects to expand how we integrate and link with the world around us. We now have a fast growing legal team, as I mentioned, bringing out a codec for law. The first question is, and this is a really cool idea,
Hmm.
what is a suitable international law for data? Can we construct a large body of private law that people can opt into and opt out of? You know, the United States takes a particular view on data. Europe takes a different view on data and the rights to privacy. China has its own thoughts. But the internet is it's kind of maritime law. It's kind of out there in the ocean. It's kind of no man's land. And you need a legal framework to cover you as you move your data continent to continent. And so we've really come up with a fantastic framework. But the next year and on the horizon, we would want to grow legal participation and to get people, because internally we have representatives that represent US law and European law. But we'd really like to grow that legal community um, to balance the growth in the technology as well. The next thing that we also want to look at is integrating with a lot of financial services and liquidity providers. Our network, for technical reasons that we can go into at some later stage, or if you're interested, we can. We have 3 nodes, which is kind of the secret to our scalability. We have what we call a compute node, a storage node, and a mining node. The compute nodes really act as an internet service provider. We didn't build the internet by flatly connecting a giant LAN across everyone's machine and saying, there you go, the internet. That would have horrible latency. That would just be a very bad topology. And the lack of structure in the network in Bitcoin is where its security comes from. So, I mean, it's slow and it's high latency and it's just fully connected, which is terrible for efficiently moving messages across. But that's where the Byzantine fault tolerance, in part, with the proof of work comes from.
Hmm.
So what we realized is that block creation and block storage does not have to be fully distributed. It's only the block verification that has to be done at a distributed level. You can sort of think of miners in our network as, it's not really how it works, but it's a good enough analogy. They kind of remote on into a containerized or virtual environment where they group work on a particular block. And they can remote on and off, but the actual network itself follows much more kind of a blockchain service provider infrastructure. We are very, very keen to engage with stakeholders in this space. We're approaching several telecos at the moment, and we hope to engage with more. If any of your listeners are related to telcos, please give us a call. So we have had early stage talks with Swisscom, Deutsche Teleco's on the cards, AT&T, to really
Hmm.
provide these compute nodes that can provide blockchain service can act as blockchain service providers. The storage nodes are cool because they kind of superimpose all the work done by all the miners. So one ledger will have at any given time 5,000 random miners reading and writing to it. Now, typically in Bitcoin, you have to look for 6 neighbors to establish whether there's consensus. You pick kind of 6 mining ledgers at random, and you look for your transaction if it's in these 6. And if it is, and 6 blocks have passed, you're safe to assume you've been paid. All of these 6 miners in our universe have written to the same storage node. And so that one node is a central source of truth that's kind of superimposed and stacked about 5,000 independent eyes at any given point in time. So with this being said, on our event horizon, we want to grow our compute node partners, our storage node partners, and really, really get out into the mining community. We'd like to make a shout out to all Ethereum miners. We understand that Ethereum is now considering a mixture between proof of work and proof of stake, and I'm not sure what their end game for proof of work is. We would like to say to those miners, take a chance on us. We're all about positive ROI while promoting sustainable mining. That's really why there was a lot of the thinking that went into our super hash class function that runs the proof of work mining algorithm on our network. That stakeholder engagement. And then finally, we'd really like to start growing out some very, very, very exciting sort of semantic. This is a teaser for the listeners.
Hmm.
6 months from now, everyone will be like, "Oh, that's what he meant." There've
Okay.
been a lot of really inspiring semantic web initiatives that can kind of do forward pass inference on ontologies. This is a slightly different approach to machine learning. Machine learning sort of can make a deduction on data, but it can't really tell you why. So it can train on my face the right ML model, and if you showed a photo of your face and my face, it'll say that's Andrew Kessler. But if you asked it to justify why, it wouldn't be able to do so. And legally, that's a terrible judge if it can't justify its judgment, because you can't, as a human, comment whether that was a good or bad judgment. You just have to kind of believe the ML script. What we've done is partnered with people that provide large human consensus maps of well-defined terms that can do first-order predicate logic and can make inference. And we've got several very ambitious projects in that space. But imagine if you were developing a token for ICO and you didn't want it to classify as a security. You've got to put in a lot of development hours, get a lot of community support, then you go to the SEC or FINMA only to be rejected. In the following year, we'd very much like to start building out through RDF frameworks, ontologies, and forward pass inference, a way that developers can kind of get a pre-ruling from their machine as to the token they've created on our system, what would that be classified as? And although that's not sort of legally binding, and we have to make it more and more accurate as time goes on, that can really save a lot of developer hours. So just to sort of recap at very high level, we want to engage with developers through a very interesting API layer, which we can discuss at some other future point. We want to engage
Mhm.
with developers by creating projects that leverage off of graph theory and ontologies to accelerate what they're trying to do. Who wants to go and sit in front of the SEC? Who wants to sort of try and round up investment by pitching your idea wide field? So we will provide infrastructure for all of that. And then furthermore, develop out law and develop out our smart data supply side.
Cool. Well, it sounds like you guys are got a lot of stuff on the horizon too. So it's it's cool. It's exciting to see you guys got those things in the works and partnerships and whatnot. And it's sounds like a really good thing for blockchain to have that because it doesn't seem like a lot of that's really out there. So you guys seem pretty unique in that sense.
Yeah, thanks, Brandon. We certainly, if somebody was to pay us a compliment, the compliment would be that we took the challenge laid down in 2012 and 2013 quite seriously and
Hmm.
tried to sort of extend that line of thinking. If you have something of value, if you have a GDP of data, you have goods and services that are data based, and you have a native currency that's a good means of payment to exchange this for, you become value backed. That's the world that I would like to live in. I would also like to have the choice behind control, privacy, and so on and so forth. And all of this has to be done with respect to government to say that it's a misunderstanding to say that blockchain isn't governed. It's self-governed algorithmically. That's the point. It gets the same level of compliance and good order. It's not the Wild West. I think that was maybe mismarketed by early Bitcoin enthusiasts. And no one was
Hmm.
trying to propose that here's a fraudulent cash base that has no audit potential whatsoever, and this is how you avoid the receiver. That wasn't the idea. The idea was that you didn't need human labor. You didn't need a central body to sit down and approve, like the Fed, how many tokens to issue. You didn't have to check that the tokens were in good standing because it was self-correcting algorithmically. And that's all we're saying. So we're not trying to avoid governance. We're not trying to sort of be confrontational. We're just trying to work with everyone.
Hmm. Well, that's good. I mean, I imagine a lot of them will want to work with you guys too, because I mean, what you are offering in terms of, a blockchain with Zenotta is, again, unique. Being able to have that kind of a function in the space, especially when no one's really thinking about it, and it's good to take, everything from 2012 to 2013 that a lot of people have kind of brushed over and forgot about, because it's gotten so corporate and institutional now, and it's all about investing and finding the best speculative play, and then there's so much happening from a technological side that's just all over the place. So
If
it's good to yeah.
I could put a soundbite to that, we've built a digital society through using internet-based infrastructure. And I would like to propose that we think of this digital society as 1.0. And in the 1.0 release, we had to give up a lot in order to get relatively little. If you read fanboys and zealots of internet technology, they'll say, hey man, if you've got an issue with privacy, then the internet isn't for you. This is just the price you pay.
Hmm.
And we want to go back to digital society and reboot it to 2.0. And why that is a good way to think about it is, what are the organs of state that any civilized society will develop? It's economics, law, and social value. Where is the applicability of blockchain? It's in economics, law, and social value. We can give people back in Digital Society 2.0 the right to privacy. We can restore news. Fake news is a thing of the past. We can go and provide financial instruments, very importantly, that can be accessed by anyone. This isn't, GameStop is a very controversial topic, but what it certainly highlighted was the disconnect between the haves and the have nots in terms of how financial products are put together and how they're trafficked and sold. And we don't want to weigh in on either side of that debate, but what we have to say is there has to be a better way. It's always about finding the middle road. And when we rebuild a digital economy that's based on actual data, not the hash of data, not a token that represents some other data, but the data itself. And when we have a legal framework to defend your rights, I think then we really onto something that's fantastic.
I think that's a pretty good soundbite. Maybe we'll use that one.
Lead with that and then plug into everything else. Fix it in
Absolutely.
post.
Maybe in like a clip or something, or on SoundCloud. Um, but yeah, where can people go to learn more about Zenotta? Like, do you guys have like a Discord or a blog or a Telegram, or um, where should people go?
So Brandon, we've had a real challenge in that this is a kind of project, because it is very ambitious. It's very
Hmm.
easy to have a project of this nature be hijacked. There can suddenly come very strong economic pressure to just become another NFT player or build that app, and we're really about the infrastructure. So we've had to be, unfortunately, in stealth mode probably longer than we should have been.
Oh, okay.
And I mean, we've really taken 5.5 to 6 years to code all this up. So I mean, our protocols are already running. The mainnet's already live. We just haven't advertised it. So
Hmm.
now that we're sort of coming out of stealth mode, people can find us on our website only right now. And please, the community mustn't take that as a sort of a lack of attempting to engage. We just
Hmm.
need to control the space very tightly, um, to give our beautiful child its best shot at its early years. We are
Sure.
now becoming more prevalent on Twitter and LinkedIn and several other sort of social media channels. But we really want people to register their interest. You'll be surprised how quick a turnaround you get. You can email any one of us on the team. Uh, Many of us have LinkedIn profiles as well. Drop us
Hmm.
a note. And let's take this conversation forward. And if you go to our website periodically, it updates fairly regularly. And as we have more, we are looking at a Discord channel. We even thought about using Clubhouse at one stage. And so all of that
Hmm.
will be communicated over the next 4 to 6 months as we increase our public visibility.
Yeah, Discord would be a good idea, because then you guys could build a really good community out and bounce around tons and tons of ideas. I know a lot of different projects love having that. It's just from an engagement standpoint and getting feedback and ideas, it helps. It helped you guys a lot.
We're very excited about that.
Yeah, well, maybe we can get on Clubhouse and talk about neuroscience and biochem too.
Brandon, I'll take you up on that anytime.
Okay, cool, cool. Anyways, I'm gonna let you go. I got to run and do a few other things, but Andrew, thanks for coming on and talking about, geez, so many things. Where do I want to start? I mean, other than everything with Zenotta and quantum computing and what the hell is going on with Bitcoin and everything from 2012 to 13, how's that shifted to now? I mean, we covered so many different topics. So I think my audience will really enjoy it, the wide diversity of it all. So thanks again for coming on and having this conversation. A lot of fun.
Brandon, always a pleasure.
All right.